So the last two exponent rules we have to do deal with division. So in section 4.4, we're going to do the division property of exponents. So there's going to be two properties we're going to cover today. So the first one is called dividing powers with the same base. And so hopefully you remember that when we were multiplying powers with the same base, we added up the exponents. And so what we're going to do when we're dividing powers with the same base is we're going to subtract those exponents. So if you look at the actual examples in the blue box, it says if you're dividing 2 to the 6th power by 2 to the 2nd power, you would subtract those exponents. You would take 6 minus 2 and you'd get 2 to the 4th power. And you know, I like to help you think about that as an expanded exponent. So if we expand 2 to the 6th, we would have 6 2's in a row. And on the bottom, we would have 2 2's. So if we took 2 to the 6th over 2 to the 2nd and we expanded it out, that's what it would look like. And remember, anytime you have the same thing on the top and bottom of a fraction, as long as you're multiplying or not adding anything, so if you had like 3 over 3 and you did that, you're really canceling everything to 1, right? So think about having 2 over 2. That would cancel, and this other 2 over 2 would cancel. And the 4 2's on the top would have nothing left to cancel with, and so that's why the final answer is 2 over 4, 2 to the 4th power. Even if the exponent's bigger on the bottom, let's expand the one with variables out. If we had 4 x's on the top and we had 7 x's on the bottom, let's take me a minute to write those. Hopefully I counted right there. Yep, 7. The 4 on the top would be able to cancel 1 by 1 with the ones on the bottom. So I'd cancel 1x on the top with 1x on the bottom. And what's left is 3 x's on the bottom, right? And nothing on the top. So those are the 3 x's that are left on the bottom. And remember, we never leave an empty numerator, so that's why we stick a 1 on the top. All right? So that's why it makes sense to subtract them. Now, there's 2 ways I've taught this in the past. I've taught people to subtract wherever the exponent is bigger, and I've taught people to change all the exponents to positive before you do that. And using those 2 rules, that usually helps. So you don't have to do it this way, but some helpful tips. So let's just call these tips. Change all exponents to positives first. So let's just make a 1 there. And second, subtract where the exponent is bigger. And so we're going to re-look at that second example in the blue box. So where exponent is bigger. Sorry, I can't write and talk at the same time. There we go. All right, so if we would have subtracted where the exponent was bigger on x to the 4th over x to the 7, 7 is bigger than 4, so we would have subtracted at the bottom. So if it were me doing this problem, I would have told you to leave the x to the 7th at the bottom and subtract the 4 down there because 7 is bigger than 4. That would have left you with x to the 3rd at the bottom, and again, we don't leave empty numerators, we put a 1 up there. So that's how I would have done it. I never would have made the exponent of 3 negative and then moved it. I would have just subtracted down in the denominator at the beginning of the problem. All right, so that's how I'm going to do these problems. So in example 1, we have 3 to the 5th power over 3 squared. So we're dealing with something that's completely numeric, but we still are dealing with bases and exponents. And so the exponent of 5 is bigger at the top. So I would tell you to leave the 3 at the top and leave the 5 alone, but drag that 2 in the denominator to the top because we want to always subtract where the exponent's bigger. So we end up getting 3 to the 3rd power. And I would be fine with you leaving 3 to the 3rd power, or if you wanted to tell me that 3 to the 3rd power was actually 27, I would be fine with that too. So in example 1b, we have another example where we have a base of 3, but this time the exponent is bigger in the denominator. So what I would tell you to do there is leave the base and exponent in the denominator and drag the exponent from the top down to the bottom and subtract down there. Again, don't leave an empty numerator, put a 1 up there. So we end up getting 1 over 3 to the first power. And remember, because 3 minus 2 is 1, but remember, we don't usually show that. We keep the exponent of 1 invisible. All right, let's try it with some variables. So if we move over to C, we have m to the 4th power and m squared. We now have a negative exponent. So if you look at that rule up above, the number 1, it says change all the exponents to positive. So if we're going to do that, we're going to move m to the 4th down below, right? So I'm going to rewrite that problem with all positive exponents. Put a 1 in the top because we don't leave an empty numerator. Well, now we don't need the new rule at all, right? We're not even going to subtract because we don't have division happening anymore. Our m's are right next to each other. And remember, that's the old rule. When you have 2 of the same base, you add up those exponents. So 2 plus 4 gives you 6. So sometimes when you change all the exponents to positive, then you won't have to do subtraction at all. And sometimes you will. You're going to see some examples where we will. All right? Okay, so let's move on to D. So if we change all the exponents to positive before we do anything, we're going to have 3 over 2. We're going to leave u to the 4th, the u at the bottom. We'll bring the v squared up and the other v down below, and we're going to show that invisible 1. So I'm going to rewrite this problem with positive exponents. This is the only time that I usually worry about the negative exponents and turn them positive at the beginning of the problem instead of the end of the problem, is when I'm dealing with division. Oh, and I should show that invisible 1 on the u also at the bottom. All right, we're going to now subtract where the exponent is bigger. So first of all, think about 3/2. Remember, that's a coefficient. Those two numbers are coefficients. You should always think, can I reduce 3/2? But you can't. So you're going to leave 3/2 alone. We're not going to do anything with those coefficients. And then we're going to subtract the u's at the top, right? Because we have a 4, which is bigger than a 1. So we're going to do u to the 4 minus 1. The v's are also going to get subtracted at the top. We're going to have 2 minus 1. So if we do that subtraction, we'll get u to the 3rd power at the top and v to the 1st power, which again would just be invisible. Any first power is invisible. Okay? So we did have to do subtraction because we had a quotient happening, and it was easy to do because we changed all the exponents positive. So when we do that first rule up there, that change all the exponents to positive, it's actually a tip, it's not a rule. When we do that, then we don't have to worry about subtracting negative numbers and worry about double negatives. All right, 2 more. Let's try 2 more. So in this one, again, if we rewrite that, although, well, let's rewrite it, but what's really going to happen is this u to the negative 3 is going to move down and this one's going to move up, right? So really, it's going to look like we did nothing, but really, we're moving those to opposite places. But they happen to be the same thing. And what you should know about whenever you have the same thing on the top and bottom is you can cancel that out. U to the 3rd over u to the 3rd is just going to cancel. But if you forget that, when you go to subtract, 3 minus 3 is 0, and u to the 0 power is just 1. So if you forget that the same thing on top and bottom can just cancel, you'll eventually get something to the 0 power, which would then turn it to a 1. You could have done that at the start of the problem. We didn't really have to move anything because we said we had the exact same thing on bottom as we do on top. So if you have that happening, remember those can cancel because that turns into a 1. So whether you do it at the beginning or in a middle step, it really doesn't matter. I think I've told you about the properties of exponents. There's not really one right way to tackle these problems. There's multiple ways. So I'm just teaching you some of my favorite ways. All right, so what we really have left is just the v's. V to the 3rd is bigger than v to the 1st, so I'm going to subtract in the denominator where the v to the 3rd is. I'm leaving an empty numerator, so I'm going to stick a 1. And the final answer then is 1 over v squared. Whoops. All right. And then finally F. again, remember that anything to the 0 power is 1, so I like to cross those off. That's just going to disappear and become a 1. And in this case, 2 over 4, again, those are coefficients. If I asked you, is this okay to leave something like that, 2 over 4? Hopefully you'd say no and say it's supposed to be 1/2, right? So 2 over 4 should reduce to 1/2 because that's how we deal with our coefficients. We always simplify them. We don't add them, we don't subtract them, right? We're not dealing with exponents when we're dealing with 2 over 4. We treat them like we always would have. 2 over 4 should be reduced to 1/2. And now we'll deal with those exponents. We have a to the 3rd power, which is bigger than a to the 2nd power, so we'll subtract in the denominator. And we end up with 1 over 2, again, a to the 1st. I must like the 1st power today. Again, that could be invisible. And so we have 1 over 2a. All right, so if you have a quotient, and you know you have a quotient because a fraction bar, right? That fraction bar means you're dividing. That's a quotient. Fractions are the same as division. Then you want to subtract the exponents, and I like to do it wherever the exponent is bigger. And I think the good tip, a good rule of thumb, is to change all your exponents to positives at the beginning of a problem, and then to subtract where the exponent's bigger. All right, so that's our first rule. What do we do when we divide powers with the same base? The next rule is kind of similar to what we learned in the Zoom session on Monday. It says, well, what if we have multiple things happening inside of our division? So if we have multiple things inside of our parentheses, we have to raise that power to every part of the quotient. So again, think like distribution, right? Think distribution. All right. So we have parentheses, and that's how we know we should distribute, just like we do when we have equations, right? We know when we have parentheses, we should distribute. It's kind of like distribution. All right, so in our examples in the blue box, it says if you have 3/5 to the 3rd power, not only is 3 to the 3rd power, but so is the 5. The 5 is to the 3rd power. When you look at those, don't subtract anything, right? Those are not the same base. 3 and 5 are different bases. So really all you could do if you wanted to is to change that to 27 over 125. There would be nothing else you could do with that. Same with the variable example they gave us here. X over y to the 5th power means the x is to the 5th power and the y is to the 5th power. Again, think like you're doing distribution. So we get x to the 5th power over y to the 5th power. Again, there's really nothing more you can do with that because the bases are different. Remember the rules that we've learned so far? We needed bases to be the same if we wanted to add or subtract or multiply. And we don't have bases that are the same. It would even work with fractions. If we had a fraction as an exponent, we could distribute that. Now, I'm not going to give you any fractions in any kind of quiz or test, or even on your homework, but you really could do it with fractions too. You could do a to the 1/2 power over b to the 1/2 power. Looks really strange, right? That looks really strange, but that would be exactly what you should do. All right. There's this other rule. If I raise a quotient to a negative power, we don't have to know this rule to get the negative powers right, but I think this rule makes things easier. If you have a negative power, so when we get down to example 2c, you're going to see we have a -4 on the outside. So when you have a negative exponent, in order to turn that exponent positive, you could flip the quotient, which just means flip the fraction, right? Remember, quotient is just the fraction. Flip the fraction that's inside the parentheses. That's actually going to turn the exponent to a positive number, and then we'll follow the rules above. So when we get to 2c, I'll show you what I mean. But let's start with 2a. In 2a, we have 3x over y. So we're going to distribute that 4 to the coefficient and to all the variables. Remember, that's the same rule we did when we were multiplying. If we had instead 3xy to the 4th power, remember this from Zoom, you would distribute that 4 to everybody, right? But this time we're dividing, but it's still inside parentheses. The parentheses mean everybody's getting taken to the 4th power. So we have 3 to the 4th power, x to the 4th power, over y to the 4th power. I would be fine with that if you want to leave it like that. Or, of course, anytime we have numbers, if you want to turn that 3 to the 4th power into a final number, which would be 81, you could do that too, except that I can't write an 81, it looks like. All right, 81x to the 4th power, y to the 4th power. Both of those answers would be completely acceptable. But the important thing to notice is the 4 on the outside has to get distributed to everybody inside the parentheses. Now, when we get to B, we could do that. We could take that 4 and we could distribute to everybody. And hopefully you'd notice y to the 0 power should be canceled, right? Cancel that out. So we could definitely take this 4 and distribute to everybody, and we'd probably get it right. But what I think makes more sense is to simplify inside the parentheses first if possible. So I'm not going to worry about the outside 4 until I simplify inside the parentheses. And the reason I know I can simplify is because there's an x on the bottom and there's an x on the top. There's 2 x's. I know I could combine those, right? So what I'm going to do is rewrite the inside of this parenthesis with all positive exponents. And so I'm going to have 2x to the 3rd power. I'm going to bring that x to the 4th power to the top, and then I'm going to have y to the 3rd power. There is nothing left down below, and we're going to take that whole thing to the 4th power. I'm really still not done simplifying. I have x to the 3rd power and x to the 4th power. Remember, when we have 2 separate bases, we can add up those exponents, and we'd get x to the 7th power. And there's nothing we could do with y, so we'll leave y alone. And now we'll finally distribute. So we'll distribute that 4 to the 2, to the x to the 7th, and to the y to the 3rd. So we would have 2 to the 4th power, x to the 7 times 4, or the 28th power, and y to the 3 times 4, or the 12th power. And I think I told you, this is where students start getting confused. Like, oh, was I supposed to add? Was I supposed to multiply? Notice up above, I added the 3 and the 4, right? I added this 3 and this 4 because I had 2 separate bases. When you have 2 separate bases, you add up your exponents. But down here in the next step, I multiplied my exponents because when you have a single base with multiple exponents, that's when you multiply. So I told you, by the time we get to the last rule, sometimes students start getting all the rules crisscrossed in their head. It gets a little bit confusing. All right, 2 to the 4th power, 16, and we have x to the 28th, y to the 12th. And I really would accept either answer. Yeah, I would take either one of these. Most books are probably going to turn it into a 16, though. All right, so again, at the top of the problem, what my point was on this one is you could distribute the 4, but you could also simplify the inside of the parentheses first, and that's definitely what I prefer. I like to simplify the inside of the parentheses first before I worried about that outside 4. All right, I'm not going to give you very many negative exponents on a quotient problem. I might only give you probably one, and this is that last rule here, this raising a quotient to a negative power. When you're raising a quotient to a negative power, again, let's read the inside of that blue box. It says flip the quotient. Now, when you flip the quotient, you're not changing any signs. And I know that can be confusing. You're going to put 4x to the 3rd power y squared at the top. You're going to put 2y to the negative 3rd at the bottom. The flipping this time changes that outside 4 to a positive 4. So in this case, the flip only turns the exponent positive because what's really happening here is you have a whole parenthesis that's being raised to a negative power. So it's like you're taking 1 over that to the 4th power. And when you have a fraction in a denominator, it really just flips. All right, so that might have gone a little too far, but that's what happens. Okay, now that I have a positive exponent, you might think I want to start distributing, but remember what I did in example 2b. I simplified the inside of that parenthesis first. So I'm going to rewrite the inside of that parenthesis with all positive exponents. And so, first of all, 4 over 2 is just a 2, right? If you take this 4 over 2, think about that. That's just a coefficient, set of coefficients. If I gave you 4 over 2 before, you would have made it a 2. X to the 3rd is going to stay on top. Y squared is going to stay on top. Y to the negative 3 is going to move up now. Now I'm going to add up those y's. So I'm going to get y to the 5th power raised to the 4th power. And now I'm finally going to distribute. I don't like to distribute until I clean up the inside of the parentheses. So now if I distribute, I end up with 2 to the 4th power, x to the 12th, again I have double exponents, and y to the 20th. That's fine. Or I got a 16 again, 2 to the 4th power, 16. So 16 to the x to the 12th power, y to the 20th is also another equally correct way that I would take on a quiz or a test. So the moral of the story is if you have the same exponent inside the parenthesis, the same variable inside the parenthesis, you actually could clean up the inside of the parentheses before you deal with that outside exponent. And if you have a negative exponent like in C, you could flip the entire fraction first. That'll turn that outside exponent to a positive 4, and then start the cleanup on the inside of the parentheses. So usually by this point, students are getting a little bit overwhelmed with exponent rules because it's a lot. And so the good news is that we will practice all of next week before we take the quiz the following week. So don't panic yet. We have a whole week to practice before we move on to the test.